So in this week's Debugged Junior, we're going to be thinking about computer games and how a computer game can make it feel like you're actually playing a human player when actually maybe you're just playing the computer. So we're going to be talking about computer games, but to start with, we're going to go low tech and we're going to have a go at playing table football. But in the end, we're going to be thinking about how everything we talk about applies to big games that you will have played at home, things like Minecraft, FIFA, maybe platform games on your phone. Here we want to think about what kind of challenges you have writing computer programs, as you've seen in previous videos that we've shown, when all you can do is simple steps in maths. How do you all turn that into a really big blockbusting computer game? We've got Mike here, he's gonna help me. So he's gonna be my human player. We're gonna take it in turns. I missed. Okay, so that was an interesting move, right? So if you're thinking about playing a computer game against a computer opponent, for a start, it's probably not going to be taking turns. Everything's going to be happening in what we call real time, really fast. Your computer game probably shows pictures at around 60 pictures a second. So the computer's got to work out how to move people around, move the ball around, all really, really fast. So we've been thinking about playing a game, sort of player versus another player. But really what we want to think about in this video is what happens if we make the other person disappear and we get the computer to do all the thinking and moving everything around. So the first thing we need to think about if we want to get a computer to play a game like this, which of course could really be a game like FIFA, which is got flashy graphics and it looks really impressive. At its heart, it's moving around a football and some players, but there's some really smart stuff in there, getting the players to kind of move like they're real, kick the ball like they're real. The ball feels like it's moving around realistically. So how do we get all that to happen? So as we've seen in other videos, computers work with numbers. So all we have really is numbers to try and describe our football game. So the first thing we need to do if we're putting this into a computer is we need a way of saying where all the players are positioned. So where on the field are they all at any one point in time? The players are important. The other thing that's really important is the ball, of course. So if the ball's moving around, then we need to be able to describe how the ball's moving and where it is. And this comes down to numbers again. We need to be able to say where it is, which is kind of a bit like a map coordinate. So it might be so many meters this way, so many meters this way, and that's where our ball is. One thing that we should think about is if a computer player is going to kick the ball, the computer needs to decide which player it's going to move towards the ball and where it's going to kick it. So there's a lot of questions that the computer is going to have to make decisions about how to answer. So once the computer's moved a player close to the ball, then it's got to decide which direction it's going to kick the ball in. So how does it do that? Well, maybe it tries to aim the ball towards the goal, or maybe it tries to aim the ball towards another player. So the computer's got these decisions that it needs to make really quickly because this is all happening as you're playing football. So the computer needs to have some kind of understanding about what a good move is in a game of football. The computer has to make decisions about how to move all the players around, not just one player. So if we think of this situation here, so we've got two computer-controlled players that can both sort of run forward and try and kick the ball. Which one's going to run and actually kick the ball? A sensible set of instructions here would be, this guy has a good shot straight ahead at the goal. So as a computer, I'm going to say he should run forward and take a shot. And if I'd have scored then, that would have been amazing. The computer is working through thousands and thousands and thousands of these instructions every second just to figure out where to move all the players at once, where the ball's moving, and what decisions it has to make. So who should kick the ball, and where should they kick it, and what direction they should kick it in, and how fast and how powerful. And as we've seen in another video, all a computer can do is just follow really simple steps, simple instructions. So we have to break down all these decisions into something a computer can understand. So let's think about one of these instructions in a bit more detail. So let's give our goalkeeper here a bit of intelligence. So we're going to get Mike back again, and we're going to imagine that we're taking a penalty. We don't need to worry about all the other players. There's just one thing happening here that we have to try and sort of get the computer to understand. If someone's taking a penalty against you, do you dive left? Do you dive right? Do you go high? Do you go low? Have a think about that, and then we can think about what rules, what instructions we can give the computer to follow. So the simplest instruction we can give the computer-controlled goalkeeper is to say, if someone shoots a ball at you, dive left. Okay, here we go. Okay, I've scored. So the computer dived left, and that didn't work out very well. So let's try again. Also not very good. So let's try again. So this isn't looking like a very good instruction to follow, is it? Just as if you were playing a real game of football, probably always going left isn't the best decision in the world. So another idea would be, let's tell the computer that it can go at random to the left or to the right. So if you imagine tossing a coin, and if it lands heads, we go left, and if it lands tails, we go right. Okay, so there's no real intelligence being built into the computer here, but it's going to seem like when you're playing the game that it's making a decision whether to go left or right. So let's see how that works out. Okay, let's try again. Okay, here we go. Ah, saved it. So far, our computer-controlled goalkeeper hasn't been very smart. They're either always going the same way or they're going randomly left or right. So what other information could they use to try and guess which way the goalkeeper should dive? Well, perhaps they could use the distance from the player to the ball, so whether you take a long run up or not, to have a guess at whether you're going to kick the ball fast or not. So distance to the ball could affect how fast you're going to kick it. Perhaps also what direction you're facing. So if I'm straight on the ball like here, maybe it's more likely I'm going to go straight ahead. So there's a lot of information you can build in that's not just making a random decision going left or right. There's stuff happening on our tabletop game here, and there's stuff happening in a computer game that a computer can try and learn to make sense of for where it should dive, just as if you're playing a real game of football. So we've looked at a few little examples here, but obviously if you're trying to develop a computer game which is playing a whole game of football, there's loads of these instructions that you need to think about. And the more of them you have, the more realistic your games can be. And actually, the more powerful a computer you'll need to run them, because you've got more of these instructions happening per second. So what we're doing is we're kind of adding intelligence to our players here on the board. And that's really what the core of AI is, artificial intelligence. It's using clever ways to program computers to make them behave a little bit more like a person. We're going to explore more of these topics in future DeBuggedJNR videos. Goal!